Welcome to the EFAS webinar on the new notification criteria and the area of validity. This webinar will cover the following topics. First, we'll talk about the analysis of the flood notification criteria, and then the new flood notification criteria. Then we'll talk about the area of validity of the flood notifications and the updated flood notification emails. Finally, we'll talk about updated map viewer layers and some upcoming EFAS events.
In the next 3 slides, I will present the analysis of the flood notification criteria that has triggered the changes in the notification criteria and the layers in the map viewers that we will see in today's webinar. Here on the left, I show the current flood notification criteria, and I have highlighted the main points. So at the moment, formal flood notifications are only issued for catchments with at least 2,000 square kilometers, with at least a lead time of at least 2 days. And then, as you may know, EFAS is based on 4 meteorological forecasts, 2 of them probabilistic and 2 of them deterministic. And the current notification procedure looks at these 2 types of forecast independently. So we issue a flood formal notifications when at least one of the probabilistic models predicts probability of receiving the 5-year return period of at least 30%, and one of the deterministic models also predicts this exceedance of the 5-year return period, and all of this needs to be repeated for 3 consecutive forecasts. So we look independently to deterministic and probabilistic forecast. There's a probability threshold of 30% and a persistence of 3 consecutive forecasts. These criteria have been there for quite some years, but EFAS, the modeling chain, has changed in the last few years. So it was high time to revise this notification and see if we can slightly improve the skill of the system. And at the beginning of the analysis, we had the questions that you can see on the right side. So the main question is if there was a better way to combine the 4 meteorological forecasts into a grand ensemble and hence improve the skill of the system. And then if that was the case, what is the best probability threshold? Is persistence still a meaningful criterion? And then can we reduce the minimum catchment area? To answer these questions, we used EFAS simulations from October 2020 to June 2023 at the fixed reporting points. To observe these charts, we used EFAS reanalysis, meaning simulations using meteorological observations. The predicted discharges are EFAS forecasts, meaning simulations using meteorological forecast. And the methodology is rather simple. We rerun the notification procedure for all possible combinations of the criteria, and then we select the combination that performs better. What combinations have we checked? So the grand sample, meaning the combination of the 4 meteorological forecasts, we tested 4 approaches. One is the current approach that looks independently to the deterministic and probabilistic models. The second approach is a simple mean over the 4 models. The third approach is a weighted mean that is weighted based on the number of members of each of the models. So to say a quantity weighted approach. And the fourth and last approach is skill weighted. It's an average weighted by the skill of each of the models. So to say a quality weighted approach. In terms of probability threshold, we tested values from 5 to 95%. I remember here that the current value is 30%. And in persistence, we tested increasing values from no persistence, what I call here 1 out of 1, up to the current value of 3 out of 3. And to select the best combination of criteria, we use the F-score, which is a metric particularly suitable for imbalance classification tasks like this one. The results show that the best combination approach is the skill weighted. So we built a grand sample from the 4 meteorological forecasts based on how good they perform. On the right, you see a plot that shows the weight associated to each of the models for every lead time. Blue colors represent probabilistic models, orange color deterministic models. The idea that you need to take home is that when in the future you will receive notifications referring to total probability, and this total probability is a combination of the 4 meteorological forecasts based on how good they are. When we use this grand sample, the best criteria is no persistence and 50% exceedance probability. The plot on the right shows why we selected this criteria. You have on the y-axis the skill metric, and in the x-axis the probability. There are two lines representing no persistence for the orange line and the current persistence of 3 out of 3 in the blue line. And then there is a black cross that represents the current criteria. So no grand sample. What we see is that the grand sample outperforms the current procedure. And if we want to maximize the skill, we need to go for no persistence, meaning the orange line, and a probability threshold of 50%. The next change in the current criteria is that we will reduce the minimum catchment area to 1,000 square kilometers. The plot on the right now shows the skill versus minimum catchment area. Black line represents the current criteria, and the blue line, the new criteria, meaning grand sample, no persistent, and 50% exceedance probability. As expected, the skill increases with catchment area, but what we want to look here is the left from the current limit, which is 2,000 square kilometers. If we take a new limit of 1,000 square kilometers and the new criteria, we still outperform the current situation, but we cover a much wider area. And the last modification is that we have put an upper limit on lead time to 7 days. The plot on the right now shows skill versus lead time. Again, the same two lines. Black is for the current criteria. Blue is for the new criteria. In both cases, skill drops with lead time. And we consider that the skill is rather poor from 7 days onward. So notifications will focus on the lead time range from 2 to 7 days.
Now we have an overview of the current versus the new criteria. So both in the current criteria and the new criteria, in order to receive flood notifications, EFAS partners need to have a conditions of access agreement. Under the current criteria, we send formal flood notifications for areas greater than or equal to 2,000 square kilometers and informal notifications for catchment areas greater than or equal to 1,000 square kilometers. Under the new criteria, however, we will send formal notifications for catchment areas greater than or equal to 1,000 square kilometers and informal notifications for areas greater than or equal to 500 square kilometers. In terms of the forecast probability, under the current criteria, formal notifications require at least 30% of the ensemble members and at least one deterministic forecast to exceed the 5-year EFAS return period threshold. Under the new criteria, we use the total probability, and formal notifications are sent if the total probability is at least 50%, and informal notifications are sent if the total probability is at least 40%. In terms of the forecast persistency, under the current criteria, the probability criteria for the ensemble members needed to be met for at least 3 consecutive forecasts. However, under the new criteria, the total probability criteria only needs to be met for the latest forecast. And then finally, the event lead time with respect to the forecast time. Under the current criteria, we send formal notifications if the lead time is greater than or equal to 48 hours. And under the current criteria, we send them if they're greater than 48 hours lead time. We also wanted to clarify the area validity of the flood notifications. An EFAS notification is valid for the upstream and downstream river stretch with the same name that exceeds the 50% total probability threshold, or 40% for informal notifications, that is shown in the flood probability layer in the same country. To help explain this, we included some examples. In this first example, we have 2 rivers. We have River A that's in blue and River B that's shown in red. If we have a reporting point on River B, then this flood notification covers both the upstream area and the downstream area for all of the River B. So all of the red area. If we have an area in River B that exceeds the 50% total probability threshold, let's say there's these red areas, and then we also have a stretch of that river that does not exceed the 50% total probability threshold, then one flood notification can still cover both areas. So in this case, our flood notification here will cover the upstream and downstream red segments plus the most downstream red segment because it's the same river, the same name, and both of those segments exceed the 50% total probability threshold. What happens if we have a river that goes through 2 different countries? So in this case, we have the same rivers again, River A in blue, River B in purple, and in red. In this case, if we have a flood notification here in the purple area, then because it's in a different country, it's in country one, that flood notification is only valid for the upstream and downstream area of River B that is located within country one, so the purple region. Then we have a second flood notification in the red stretch of River B, and that is valid for the country two segment of River B. So just the red upstream and downstream of that flood notification and reporting point. The flood notifications are valid for the River B segments in their respective countries. And then as a final example, we wanted to show what happens if the river changes the name. So here we have River A again and River B, and then they merge, and then the river becomes River C. In this case, the flood notification for River B, this purple point here, that is only valid for the stretch that is called River B. And then River C has a separate flood notification that's valid just for River C. So in these, the flood notifications are valid for the respective rivers. What happens when you receive a flood notification email? At the top, you can find the location, including the country and river name. Then you can see information on the timing of the event, including the predicted start of the event and the earliest predicted peak. Then we have the total probability of exceeding the 5-year return period threshold and the 20-year return period threshold. And finally, at the bottom, we have the text describing the area of validity of the notification. The flow notification emails will also include a link to view more information on a notification archive. And so if you click a link in the flood notification email, then it'll take you to a website that has an interactive map that allows you to see the reporting point in the surrounding area. And if you click a button at the bottom, it opens up another window that shows additional tables and plots, such as the hydrograph and the total probability table. Now we wanted to highlight a few new updates to the EFAS map viewer. First, we have an updated reporting points layer, and you can find this under the flood summary tab. It looks similar to the current reporting points layer, except that there's only one number to the upper right of the reporting points. And this number indicates the total probability of exceeding that particular threshold. There's also the arrows that point up, down, or sideways. If they're up, it indicates an increasing probability of exceeding that threshold. If the arrow is pointing down, it indicates a decreasing probability of exceeding the threshold. And if it's a sideways arrow, then it represents a constant probability. If you click on a reporting point, then it'll open up a pop-out window that has the new total probability hydrograph and a new total probability table. Then we have the new flood probability layer. This is also available under the flood summary tab. And this layer shows the pixels in the EFAS model river network, and they're symbolized according to the total probability of exceeding the 2, 5, or 20-year return period thresholds. There's different shades of the colors depending on the probability. We also have updated 5-year exceedance layers. These are also found in the flood summary tab, and they are now based on the total probability of exceeding the EFAS 5-year return period threshold in the lead time range of 0 to 7 days. If you look at the 5-year exceedance less than 48 hours layer, that indicates the probability of exceeding the 5-year return period threshold within the lead time of 0 to 2 days. And these are symbolized in blue. If you want to see the probability of exceeding the 5-year return period threshold in the lead time of 2 to 7 days, then those are symbolized in yellow to red notes. And then finally, we have an updated major rivers layer. This is found under the static tab. When you're zoomed out in the map, then the smaller rivers are hidden. And as you zoom in, you can see the smaller rivers, and there's an improved river labeling scheme that makes it easier to read the river names. In addition, the width of the lines representing the rivers is varying depending on the river size. Finally, we wanted to highlight some upcoming EFAS events. First, we have the EFAS version 5.2 release that is currently available for testing on EFAS stage. You can find it at this link here. EFAS version 5.2 release is scheduled for release to production on August 13th of this year. And highlights include the new flood notification criteria, the updated flood notification emails, and the updated map viewer layers. You can read more about the version 5.2 release on the EFAS wiki by scanning the QR code here. And then finally, we have the EFAS annual meeting from October 24th to 25th of this year in Norrköping, Sweden. You can participate both online and on-site, and the highlights include discussions on evolutions to the EFAS systems, EFAS issues, and opportunities for improvements to the EFAS system. If you participate on-site, we have workshops on technical topics, including the forecast verification, providing feedback for notifications, flood hazard maps, and tips for using the EFAS map viewer. We will also have an on-site feedback collection poster to gather suggestions for improvements and adjustments that we can implement in the next EFAS release, version 5.3. Registration for on-site attendance closes August 31st, but if you want to receive reimbursement for the traveling, then you need to register before July 15th. And you can register by scanning the QR code here. For further information, you can go to our website, www.efas.eu, or send us an email at info@efas.eu.